So it's 2 minutes past the hour, so I think we can go ahead and get started. My name is Jeremy Gregory, and I'm a research scientist at MIT and the executive director of the Concrete Sustainability Hub. And I'm delighted you can all join us today for a discussion about environmental product declarations and challenges and opportunities of using them in environmental performance comparisons of concrete. This is going to be a tag team effort between myself and our postdoctoral associate, Hassam Azari Jafari, and I'll do the first part and he'll do the second. And so to kick it off, what I wanted to do was first, I assume you're here because you've heard of environmental product declarations or know something about them, but just in case, want to make sure that everyone is familiar with them. And that is basically they're like a nutrition label for the environmental impact of products. And you can see this one right here is from a concrete company that tells a little bit about the product it has and a little bit about the performance. And then over here we have environmental impacts here. So energy consumption, water use, global warming potential, which is like a carbon footprint type measurement, ozone depletion, acidification, eutrophication. So all of these here, it shows impacts per meters cube and impact per cubic yard. So as I said, it's a way of reporting environmental impact of products. And today we're going to be talking mostly about building products and mostly about concrete, but they are also being used in many different applications all over the world. Now, at least here in the US, the LEED rating system is a big driver of use of EPDs, and they can indeed be used for within LEED and within all the different categories here. The place where environmental product declarations are used is primarily here within this materials and resources category, and mostly they started to be used because they wanted to motivate reporting of environmental impacts. That is, they wanted companies who were going to be supplying building products to basically say, here's our environmental footprint of our products, with the idea that hopefully it would then get them to make changes. But at least in the main part of LEED, the EPDs are mostly, they just want you to use products that have that. There isn't really a direct comparison, although there are some pilot credits and proposals to change that we'll get into. But mostly, like I said, the idea is to motivate reporting of them. And I think that's great. That's definitely a step that we need. We want people to be reporting them. The good thing about EPDs, there's a whole process behind them involving product category rules and verification, so that when they come out, you can feel confident that the numbers that are being reported have gone through a pretty rigorous process. So that part is great. What's happened more recently is that EPDs are being proposed for use in procurement, that is, in government purchasing. The idea is that we should pass legislation where, whenever the government is involved in doing construction that involves building materials, they should buy low carbon alternatives. And the colloquial term for that is buy clean. And this map here put out by the Carbon Leadership Forum shows locations where there's been legislative activity. A dark color, California, shows where a state buy clean legislation has been passed, and that is in California. In all the other ones is where basically a policy has been introduced but has not passed. And that includes both state and city levels. So, and in the various forms of these proposals, what you see is that EPDs are usually proposed as the mechanism by which there would be a decision about whether or not to use a particular building product. And so while I understand that there's a data that's out there and EPDs, they're verified, that seems good. The challenge is that, right, at least the current versions of EPDs, they were created for reporting in a verified way, but not actually for comparison. And certainly when you see a lot of things about EPDs, the intention was that eventually they would be able to be compared, but at least the current version of a lot of them, they're not actually set up for effective comparison. And so if we really want to take EPDs sort of to the next level where they are used in procurement, we're going to have to change the way that we publish EPDs, or we're going to have to use some alternative tools. And that's what we want to talk about today. And our intention is not to say, let's get rid of EPDs. As I said, I think they do have a great use. If you're looking for approximate data on environmental impact of building products, they can be a great source of information, and it is a great way to get companies involved in measuring that. But when you take this to something like a procurement or other instances where specific numbers really matter, and decisions are being made, we need to take them to the next level or use some alternative approaches. So what I'm going to be talking about today is mostly about comparison of EPDs, and in particular, three critical issues about related to comparison. The first is environmental impacts. The second is about performance, and in particular, establishing functional equivalence among different alternatives. And the third is uncertainty. So starting out, the first one is environmental impacts. Now, when it comes to comparing EPDs, as I mentioned, I think one of the major intents of creating them was that eventually you would be able to compare them. And in fact, that's why in an ISO standard related to product footprints, they actually lay out, here are the requirements or different things that need to be satisfied in order to do comparisons of EPDs. So all of these things need to be consistent among different EPDs that are compared. And it's kind of a long list. So I'll just tell you that the key elements really about what's the scope of the analysis, what kind of data is used, and what are models in both the foreground and the background. And these may or may not be covered in the product category rule, which is sort of like the rules that we use to establish EPDs. And like I said, when you're creating them just for reporting, you don't have to have consistency in every single one of these things because they're not meant for a comparison. But if you are looking for a comparison, that is something that you need. And in the vast majority of cases, you'll see that's not the same among different alternatives. And just to give you an example of how much variation there can be, this chart right here is showing a study that was done by some folks at Federal Highway Administration about EPDs. And one of the things that they did is they looked into different types of EPDs for concrete, because that's the most that are published. And this right here is showing different types of background data that you need in an EPD. And the numbers here are basically different groups of EPDs that were kind of done in consistent ways. And what this is showing right here are all the different data sources that were used within each category. So for some of them, fuels, it's basically 2 different data sources. Electricity here, we have 4. For cement, it's on the order of 6. So as you can see, there basically isn't a lot of consistency across all the different types of background data. The other thing is that, when EPDs are done, it's essentially doing a life cycle assessment, and the results that you get depend on which type of software tool that you use. Here is showing something that Hassam did in basically calculating concrete environmental impacts using 2 different common life cycle assessment tools, CIMA Pro and OpenLCA, but using the same system boundaries, same background data, and same processes, but in 2 different tools. And these are 4 different types of environmental impacts or indicators. And what you can see is that, the results are, 5 to 15% different across them. And we're not exactly sure why. But, this is to say, once again, that's pretty close if you're just trying to do ballpark comparisons, and that's fine. But when it gets into instances where you're doing comparisons where the outcomes, really matter and you're going to be ranking, then that can be a game changer. And there are other folks who have looked at these comparisons of EPDs and how they can be problematic. This is some work done by a group in Canada at Ryerson University, and they compared EPDs for different types of building products, whether it be insulation, flooring, or cladding, and looked at kind of those issues around the ISO standards and whether they met the definition of comparability, and found that in the majority of cases, comparisons were invalid because they didn't meet all those different definitions for comparisons. So, to kind of sum up this portion about what it means to do compare environmental impacts and make sure we're comparing apples and apples, you need to make sure, our recommendation is to basically use one calculator. If you create one calculator and then are always running environmental impacts of products using that calculator, you'll satisfy those ISO requirements, and that's the priority for us. It could be that you create that calculator so that EPDs can be generated from that, and sure, that would be a bonus. It should be straightforward to do, but it's not necessarily the requirement. So if a state wants to set up a procurement system, they can just choose the calculator to use and then make sure that all procurement related environmental decisions are done with them. So that's our recommendation. All right, next topic is functional equivalence. And why is this important? So going back to this EPD that I showed at the beginning, it seems like there's a lot of information here. We have some, kind of like a name for this product from the manufacturer, but really the only performance information that we have is right here, and that's 28-day compressive strength and the slump. And actually, so according to the product category rule, the 28-day strength listing is a requirement, but slump and any other performance metric is optional. So in most EPDs, you pretty much just see that 28-day strength. Now, that is one indicator of the performance of the concrete, but there are many other drivers of why we design concrete mixtures in certain ways. They can be related to constructability, to durability, to stiffness, or density. And so as a consequence, it's hard to make sure that when you're comparing products from different manufacturers, even if they have the same 28-day strength, that you're really comparing functionally equivalent designs. And let me show you an example of this. This here is showing the global warming potential, or essentially the carbon footprint of 10 different mixtures that all have the same 28-day strength, 2,500 PSI, from one concrete facility. Okay, so same facility, not just same company, same facility, same strength, and you can see the environmental impact of the mixtures varies by a factor of 1.5, right? And so the reason for that is that basically these are not all the same type of mixtures. They all have different performance requirements, and we don't see that information in the EPD because they're not required to, and it's understandable as well. Let me give you some other examples of how this variation in performance can change even when we're talking about the same 28-day strength. This chart here, Hassan put together based on some data that was published elsewhere, but basically shows strength gains, and this is on a log scale in terms of number of days right here. And this is for a straight ordinary Portland cement mixture, whereas the blue line here is one that has 50% slag, and the green one here is one that has 50% fly ash. And what you can see is that the straight Portland cement one has high early strength gains, whereas the other gains strength more slowly. They all have the same 28-day strength, and in fact, some of the others will have higher strength after 28 days. So depending on what you're looking for, these mixtures are going to offer different solutions. Now, in many applications where you're looking for early strength gain, such as vertical construction, this is going to be required, but of course, this will have a higher environmental footprint. So that's just one reason why that the amount of the mixture is going to really dictate what type of performance you get, even for the same 28-day strength. Another performance issue is related to durability. This here is a figure that's meant to show basically different types of concrete that can be used. You know, some that is in probably salt water, some that's exposed to the air, some is underground, and they all have different types of durability categorizations, right? Freeze thaw, sulfate attack, corrosion, exposure to water, and you change the mixture in order to meet those. So once again, these could all have the same 28-day strength, but with different durability requirements, you have to change the mixture. And lastly, another example here is modulus or stiffness. This is a figure that Hassam put together based on a very large data set that basically shows what is the range of modulus of elasticity for a given compressive strength. And what you can see is there's significant a range here. So just because you know what the compressive strength is, doesn't mean you automatically know what the modulus is, or sometimes maybe for a given strength, you may have a high modulus requirement and sometimes it may be low. So just because we know what that 28-day strength is, doesn't mean that we know what that performance is. Okay, so how do you get around this? Ideally, you really want to be comparing concretes with identical or similar performance, okay? And there's two different approaches to go about this. If you really want to ensure you're comparing concretes with identical performance, and I kind of use that in quotes, it's hard to get exactly that, but pretty close. You could basically say, I only want to see the environmental impact for concrete products that meet a specific project specifications. So if you know you're doing a building, this is foundation concrete, report the environmental impacts for this foundation's concrete. And if we can use more performance-based specifications, that will make that all the more easier because we know exactly what the requirements are of that. In some cases, folks may decide that's not a realistic approach or something like that. So if we're just going to try to narrow it down from 28-day strength, one proposal is basically not just create benchmarks based on 28-day strength, but also use functional categories. And those functional categories might include, like I said, foundations, slab on grade, slab on deck, columns, walls. You know, that has to be decided by a multi-stakeholder group. And what happens is those functional categories then act as a proxy for other kinds of performance targets. That is, when we say foundations, you know, we're not being explicit about all those other performance requirements we need for foundations, but it's implicit. And in fact, the Structural Engineers Association of Northern California explored this when trying to set thresholds for the Marin County Low Carbon Concrete Code. That code didn't ultimately adopt those categories because they wanted to create something simpler. So they did set thresholds just based on 28-day strength. But this is an idea that's out there. We're trying to explore it for different groups. And so I think it's something that's also worth exploring. So the last topic in here is, when can EPDs be compared? And the topic of uncertainty here. Now, uncertainty includes a lot of different things, including variation and you know, uncertainty about unknowns. I'm just going to use that as kind of the broad term. But one of the things that's clear is that there is significant variation in EPD results. This here is showing an analysis that Hassam did of about 3,000 different concrete EPDs. And they're organized by basically their strength range here. And what you can see is that even within particular categories, there's significant range. The red lines here are NRMCA industry average benchmarks. And it's interesting that, you know, for some of them, they're kind of within the range, and some of them, they're quite a bit lower. So it could just be this sample of EPDs to why that is. But regardless, we see significant variation. Now, the obvious question is, what are the key drivers of variation? Is that about the performance of the concrete, as I had mentioned before, or about how the EPDs were calculated? And we don't know for sure, but it's probably a little bit of both. Here's some examples of how this variation can have consequences specifically related to the EPD component of it. So let's say we have our carbon footprint here, and the Carbon Leadership Forum has established some baselines based on EPD data. And what we did is we said, well, let's calculate environmental impacts for a particular mixture, 4,000 PSI. And we can calculate it such that we are below this threshold, and that threshold is then makes this mixture eligible for a specific pilot credit that's trying to incentivize the use of low carbon construction materials in procurement. Okay, and so we did that by using this background data set, EcoInvent, a transportation distance of 40 kilometers. Okay, now I can take that same mixture, same amount of data, and but use a different background data set, the Gabi data set, and have a transportation distance of 60 kilometers, and now I'm above that baseline and am not eligible, right? So so this is something where you know, as I mentioned, if you're looking for ballpark figures, EPDs are fine, but when it comes to actually getting really into specifics and where these kind of decisions have more significant consequences, then it matters. So our recommendation is to include uncertainty in comparisons, and Hassam is the one who put this together and has done some other work he's going to talk about next as to how we might do that a bit more. In my portion, at least, I just want to wrap up with a few other considerations for vendor selection in procurement. One is that when you're setting up procurement systems, you know, concrete producers are almost always subcontractors in the procurement process. That is, the state doesn't directly contract with them. And of course, that language can be set up, but it's just something that needs to be considered. The other thing is that there's usually multiple concrete mixtures in one bid, and there are often multiple concrete producers on one bid. So when it comes to setting up those procurement systems, you need to be able to have specific language that navigates those. A common approach proposed is to set a global warming potential threshold. And as I mentioned before, I think that should be done a multi-stakeholder process to establish functional categories. And if you're not going to do that, then you're going to have some type of weighting or prioritization scheme to deal with trade-offs among performance, cost, and environmental impact. Here's an example right here. Let's say we have 3 mixes proposed, and I've kind of normalized costs and environmental impacts. You know, for mixture A, the cost and global warming potential are normalized at 100, whereas let's say mixture B, it's lower cost but higher impact. Mixture C is higher cost but lower impact. So these are all, you have to basically have a mechanism in place to deal with those trade-offs. All right, so just summarizing, what do we think are the key elements of incorporating embodied carbon into what I call vendor selection for procurement? So when it comes to environmental impact comparisons, we recommend a single calculator for all calculations that include uncertainty. And as I said, EPDs may be an output of the calculator, and that's great, but it's not a requirement for doing those comparisons. You just have to have a calculator that people agree there is verified. When it comes to performance comparisons, if we can do performance-based specifications on individual projects and then say we want concrete compared for this application, that's a way to do it. But if that isn't an option, then establishing functional categories that acts as proxies for multiple performance metrics beyond 28-day strength. In the selection of individual vendors in procurement, we need to deal with the trade-offs among cost, performance, and environmental impact, or set up those thresholds using the multi-stakeholder process that could then account for how we do performance comparison. And lastly, something I'll just mention, but I didn't really go into much, is I think that when you set up these procurement systems, we need some incentives. It could be to help firms implement measurement in EPDs, but also we need some incentives for purchasing really lower carbon materials where we want to do deep decarbonization. Just like we do this for renewable energy, we should have that here for this as well. What I wanted to do is show a table here that compares a bunch of different buy clean procurement policies that have been proposed or implemented across the country, mostly on the West Coast, but including New York. And what I've done is I've characterized, in the policy, how are they looking to compare performance? How are they looking to compare environmental impact? how do they deal with the vendor selection, and then how do they incorporate anything for incentives? And so, I think maybe in the Q&A or elsewhere, I'd be glad to sort of get into the trade-offs among these. But my main point is just that the environmental impact, they're all relying on EPDs right now. But other than that, there are a bunch of different approaches for dealing with these other issues. So it just shows that it's still a bit of an experimental phase, which is great. The people I've interacted with who want to do this want to get it right, and I think that's great. And that's part of why we're having this discussion here, is to try to further that along. Okay, with that, I'm going to hand it over to Hassam, who's done some research on how do we incorporate uncertainty into comparisons of life cycle assessments. So even though this isn't really done effectively now with EPDs, we tried to do it as a way to shed some light on how we might have future opportunities to incorporate this into EPDs and possibly procurement. So with that, Hassam, I'll stop sharing my screen and you can take over.
Okay, thank you so much, Jeremy, for the introduction and this information, and thank you everyone for joining this presentation. I'm going to talk about the approach that we propose to include the uncertainty in the comparative analysis of different concrete EPDs or embodied impacts of concrete EPDs, and the lessons that we could learn from this comparative analysis. I start this presentation with a brief explanation of the approach and the overview of what we need to do as the preliminary steps to reach to the probabilistic analysis. So as you can see on the screen, the first step that we have to follow is the definition of a steady set of assumptions and model inputs. As you know, there are multiple methodological choices and availability of databases and allocation choices in LCA and in the calculation of the embodied impacts of concrete as well. We have to first specify what options are available and what options can be included in our analysis. And then we have to definitely include the mixed designs. So here we assume that we are comparing a target mixed design, which is our company's mixed design, against the benchmark values that we have already had from the NRMCA industry-wide program. And in the second step, we will go for the data collection to collect all those representative inventories. The priority is given to the site-specific data to minimize the uncertainty, obviously. And we will collect and calculate the background database unit processes as well. And then, as Jeremy mentioned, we will go for that 11 points mentioned in ISO 14025 to satisfy the requirements for comparative analysis of different EPDs. And to make sure that we are consistently applying the rules and the choices that we have already had. And in the last stage, we will go for the probabilistic comparison that I will show you in the next slide. And it's where we introduce different variability and uncertainty sources to our system. So here is the model and the framework that I would like to propose for probabilistic analysis of different EPDs. First of all, we can have different inputs, but we have to first characterize all these inputs. Most importantly, here we can see that we can have different discrete choices, say different methodological choices in terms of database selections and allocation choices here for different byproducts. Then we can have different variability sources, those inherent changes existing in the world, as opposed to uncertainty that might be more related to the human errors or more broadly what we don't know. And at the end, we can introduce data quality scores. You can already observe that in EPDs, there are a couple of pages assigned to different data quality scores related to the geographical, temporal, technological aspects of the representativeness of the input data that we have already had on these EPDs. We can obviously convert these qualitative metrics to quantitative values using different approaches such as pedigree metrics that we have in EcoInvent. And then we go for the Monte Carlo simulation. We have already had this database, these databases selected. We have already had a set of allocation choices for products and the data quality scores that we have, including the variability. And we apply all these sources consistently when we are comparing mixed design A, say our target mixed design versus the benchmark mixed design B here. And then we calculate the relative impacts of A divided by B. Obviously, if A divided by B is less than 1, it means that our target mixed design has lower environmental impacts than benchmark. And once we repeat this calculation for 1,000 times in Monte Carlo simulations, we are interested to know the area under the distribution that has the values of 1 or less. And this is the fraction of the results that will give us an idea to how much plausible is to have a lower environmental impacts than the benchmark value. And we apply this approach to 219 mixed designs in Ohio. Again, we have the target mixed design here on the left. We have the industry average mixed design, and we have different sources of uncertainty. The first source is the data set. Here we chose EcoInvent as opposed to Gabi, two different LCA data sets widely used in different parts of the world. And within each of these, we have different unit processes, right? And these processes have different data quality scores. So we use a pedigree matrix approach to assign the probability distribution related to the data quality scores for each of the unit process for each database. And we have different allocation choices, again, as a part of the methodological choice related to considering burden-free, meaning that it's a waste, or there is an economic allocation rule assigned to our byproducts. And lastly, we have the variability in the quantity of the constituents for a given volume of mixture. And all this sampling method was done in a consistent way, and the correlation among samples, among different products and two different alternatives was definitely considered in this study, not to overestimate the uncertainty, meaning that if we consider the EcoInvent database for calculating the environmental impacts of the target mixed design, we definitely assign the same database for that specific run to calculate the industry average mixed design. Okay, so here is the results of the standalone LCA for 3 different mixed designs corresponding to Great Lake region benchmark values. So you can see that these 3 mixed designs have different compressed 28-day compressive strength value. But considering all this uncertainty and variability that we have already introduced to our system, we see a significant overlap among these results, which may avoid us making a meaningful conclusion whether even 2 different mixed designs with different levels are statistically significant from each other. But it's also important for us to know where this variation comes from and what is the share of each source of uncertainty and variability to the total variation of the results that we can observe here. Here is the results that you can see on this donut chart. And you can see the contribution to variance in this probabilistic result. Obviously, from this chart, we can see that the majority of uncertainty comes from the methodological choices, the orange part of this donut chart, and the data quality scores, both related to Portland cement. So it's very important if you want to consider and if you want to have an absolute value of the GHG emissions for a given mixed design, we should definitely consider these 2 different sources in a standalone analysis. Let's say we want to know the kilogram CO2 equivalent for 1 mixed design. However, if we want to have a comparative analysis, the story might be a little bit different because we are considering the benchmark mixed design against the target mixed designs that we have already had from our concrete plant. And here is the probabilistic, here is the comparative results that I wanted to show you. First, 5,000 PSI, including 77 mixed designs, and here 6,000 PSI, including 42 mixed designs for the same region. And the orange dashed line show the benchmark GWP corresponding to the global warming potential of the benchmark mixed designs that we could get from the NRMCA industry-wide program. And you can obviously see that some of these mixed designs fall on the left part and some of them fall on the right part of this line, meaning that these mixed designs are eligible to get the pilot credit of LEED based on owing to having a lower environmental impacts than the benchmark values, while the others may not be eligible. However, when we see the uncertainty in our system, we can see that those mixed designs locating in the range of 367 to 407 kilograms CO2 per cubic meter concrete may not give us a resolved, statistically resolved result, meaning that we cannot specify whether the results are significantly and statistically different from the benchmark value, which is obviously from for mixed design. The same case for the 6,000 PSI mixture, 5 mixed design, 5 out of 42 mixed design fall in the statistical tie range, meaning that we cannot make a meaningful conclusion. But we can see that the rest of the mixed design, even though we have introduced a lot of uncertainty and variability sources existing in the world to our system, can give us statistically significant difference results from the benchmark values, right? And if we want to see where the uncertainty comes from in our comparative analysis, we can see that it's depending on the target mixed design, it can come from different sources. This mixed design corresponds to a water binder ratio of 0.45 and with 35% slag as replacements of the Portland cement. For this one, you can see the green part of this donut chart representing the majority of the variation and contribution to variance is the major driver of uncertainty. While when we shift the mixed design to another one, and when we are comparing that against the benchmark values in our comparative analysis with a mixed design of 0.45 water binder ratio and 20% fly ash, the majority of the variation in the results come from the variability in the Portland cement content. The same case for a mixed design that only includes OPC with the same water binder ratio. Again, the Portland cement and the variability of the Portland cement is the dominant source of uncertainty and variation into our comparative analysis. So we can clearly see that these things, contribution to variance is quite different from the standalone LCA, where we saw the significant role of Portland cement, life cycle inventory, and also the data quality of Portland cement as well. And if you want to compare them against each other, the methodological choices, the orange part of the donut chart, may not play a major role. And once we apply these rules consistently, when we are comparing the benchmark results against our target results, target mixed design results, we don't have that much worriness about the methodological choices and the allocation rules or the life cycle inventory. So for the future, first, we propose to have a single calculator that can be widely available for everyone to use and to incorporate the uncertainty and to robustly assess these comparisons of the benchmark values against EPDs or EPD to EPDs to avoid and to minimize the differences in the methodological choices. Second, we would like to have a benchmark value defined in the mixed design levels as opposed to the GWP level values, because you could clearly see that once we are changing and once we make some small tweaks in the methodological choices, we can change the conclusion on the preferred scenarios. So if we have the benchmark values in the mixed design levels, we can ensure the consistency and the application of different choices in a consistent way among different alternatives. And third one, uncertainty in the mixed designs will lead to significant overlap, even if we have different strength levels, right? But it is the case when we are comparing, when we are introducing the uncertainty to a single mixed design, as opposed to when we are comparing the mixed designs with different class, compressive strength level, and with a, comparing to the benchmark value, we can see that most of the mixed design, more than 87% of the mixed designs of our population, can show a statistically significant different results from the benchmark values. And lastly, the methodological choices may not be an important matter when we are comparing the mixed designs against each other in a consistent way. And we may not be worried that much about allocation factors or lifecycle inventory database once we are doing this comparative analysis. But what we need to be ensured is that we are considering and we are applying all these rules in a consistent way and within one single tool. So that was all for my presentation, and I'd be happy to take any questions as well. Thank you.
Great, thanks, Hassam. We have a bunch of questions, as I mentioned to folks. If you do have questions, please put them in the Q&A, and we have close to 20 minutes here to go through them. So we'll do our best to keep going through them. One of the questions that came up that I can tell everyone is that we'll definitely provide you with a copy of the PDF. So you can take a look at the work that we've done. And Andrew, who helped to organize this, will also post a link to a YouTube recording of this in case you want to go back as well. So, all right, let's get into some of the other ones. First of all, Hassam, one of the questions was about the consistency in calculation methodologies for GWP across different countries and products. Do you have a sense, Hassam? You came to us from Canada, and you maybe can go farther than just North America, but do you have a sense of like how are some of these different things calculated in different countries?
Well, I'm not very into the details of the calculation, but I know that in different parts of the world, such as in Europe, in Australia, and with some imports in Canada, those associations related to ready-mix concrete productions have already established a good basis for this calculation, meaning that you can get some of the benchmark mix designs from this association and apply your consistent rules that you have reached a consensus upon for this calculation. So I think it would be possible, and it would be quite feasible to apply this probabilistic approach to different locations and to the mixed designs in different locations as well. But it definitely needs a benchmark mix design to check the eligibility of the LEED credits or other certification credits as well.
Yeah, and there are also different product category rules that are used in different locations, right? It's not all one category rule for the world. As a matter of fact, there's another question in there about how we could account for recarbonation in EPDs. And to me, that's kind of a good example where I'm familiar with at least some EPDs in Europe that are either account for this, carbonation that happens throughout the life of the concrete, or it could happen at end of life. In my response online, I said that, or in the box, that it's difficult to do because there's such a wide variation in conditions that affect the amount of carbonation. So you could basically, in a product category rule, say we're going to specifically look at this condition, that condition, but it's hard to capture. So that's an example of where it is done differently in different locations. Okay, some other questions related to uncertainty. One of the things is about how often do EPDs need to be updated or recertified? Do you know about that, Hassam, or I can maybe answer it too?
There is some information about this in the North American PCR that puts a 5-year period as a validation period for EPDs. But if we have a single tool and an online tool that can be available for everyone, the user or the manufacturer can go there and update the information over there. And on the other part, the association or the corresponding or the responsible person for the tool can go and update the lifecycle inventory over there, so it can be valid for perpetually in that way.
Yeah, agreed. So, but generally, my sense is that 5 years is kind of because the PCR is updated every 5 years and EPDs last every 5 years, and so. Okay, there's a question about the variability analysis or the uncertainty analysis you just did, and whether you use the same Portland cement LCI data set for all the mixes analyzed. Like in particular, this is the one where you looked at the 3,000 different EPDs. Do you have a sense, I don't know if you know whether the same Portland cement LCI data set was used?
No, actually, that was the data that we could get from the EPDs. And for those EPDs, as Jeremy showed in one of his slides, there is a range of databases used already to produce these EPDs. So the short answer is no, but the longer answer is that we don't know like how many has been used.
Yeah. This was Matt Dalkey who was saying that, if some EPDs use a product-specific cement EPD, that would account for why it could be lower, right? If they chose, a blended cement or something like that. But as you said, that's what makes it difficult to know, and it just sort of supports how comparing them based on different background data sets or not having enough information, we don't know. So. Okay, one of the questions we got from Siva is kind of related, Hassam, to your SEMA Pro Open LCA. It seems like we're using the same background data set. It's just kind of, matrices, arithmetic. Why do you think those tools would be given different results?
There would be different possibilities, but again, we don't know because the calculation in these tools are quite complex because of the the development of the tool, the platform that they use, the language that they use, but it mostly comes from two major sources. First is the lifecycle inventory database and the linkage between different unit processes in database. There is a possibility that there is a truncations in some of those links. Well, there could be some technical issues, and the other part is the characterization factor precision. Once we are converting the lifecycle inventory data to lifecycle impact assessment method, there is another opportunity for raising that error or those differences as well.
Yeah. Okay. There were several questions about the use of cement EPDs. That is, we talked about concrete EPDs, and those concrete EPDs were developed because on a building construction project, you're buying concrete directly. Cement is sort of upstream. So there's been some discussion, like cement EPDs in theory aren't required for LEED, but still, recently, in the past few years, the cement PCR was updated, and then the Portland Cement Association did an industry average EPDs, and now we are starting to see company-specific cement EPDs. And so, someone asked for information on that, and I would suggest going to the Portland Cement Association's EPD program, and they can put you in touch with that. But it does add another link, kind of on building off of Matt's question about that. It could be, and frankly should be, that's a great way to differentiate different types of low carbon cements in here. But we just then need, if we are going to start doing comparisons, we would need that to be something that's a bit more, something that's a bit more explicit, so that we can really make sure that we're accounting for that as a source of variation and something that's good, that we want to be lowering the impact of the concrete. So there were a few other questions around, if we aren't revising PCRs for another several years, are there plans to, push that functional category as a requirement? And, we work closely with NRMCA and James Bogdan, who helps to run that program. At least in recent discussions with him, I have not heard that. But like I said, we're still a few years away from that. I know that, some programs like the EC3 tool, they've made it so that if someone has a lot more information in their EPD, it can be incorporated into that. And their strategy is that, let's sort of build it and they will come, and who knows, maybe that will be enough. There's nothing in the PCR that says you can't report other performance characteristics. It's just that right now there isn't really much incentive for them to do so. Now, having said that, kind of, if you are really thinking about this through a procurement lens, it could be that you make that a procurement requirement, that you have to do that as part of this program. So as I said, you don't have to think about it just through the EPDs. It could be just say, we need to know this performance information. You put it into the calculator that we've selected, and that's how you go about that. So okay. One of the questions we got was about, we really focused here on EPDs of concrete mixtures. Can you comment on efforts to use EPDs to inform purchasing decisions about different materials, like, concrete and steel, plastic, asphalt, et cetera, stuff like that? So what do you think, Hassam? Is it about the use of EPDs for doing comparisons across different materials?
This is quite difficult, even more difficult than comparing concrete EPDs against each other. And it definitely needs again, a single calculator to apply all those rules and our unit processes in a consistent way. So I would say that making a fair comparisons among different products that deliver the same function would be quite difficult if it can be done through EPDs and through separate documents.
Great. Yeah. It comes back to functional equivalence, certainly just based on knowing impact per cubic yard or per meter. And so, or per cubic yard or meter, it's hard to do comparisons, particularly when even other ones might use different units. So that's really is not recommended at all. So let's see. There's a few other questions about when we talked about a calculator or a tool. And I realize that terminology is a bit confusing, so maybe let me get into that a bit more. There are life cycle assessment tools that are used, and Hassam, showed I showed a comparison of his work looking at a CIMA Pro compared to OpenLCA. Those are something that usually more advanced users will use. It can be used to look at a life cycle assessment of anything. It's not necessarily tied to an environmental product declaration. Whereas when I talk about a calculator, I'm using that as a term. It's still a tool, but it's something that would be more specifically focused on something like calculating environmental impacts of concrete. And many of these already exist. There are several different firms that have created their own calculators. A lot of them work with companies to use those to generate EPDs. And that's why, frankly, for concrete, we have, dozens of thousands, well, at least over 10,000, probably in the dozens of thousands now of EPDs, because these calculators have made it so easy to do. And I think on their own, any individual calculator is just fine. There are differences among them that we can't always explain, but as Hassam showed, even when you account for uncertainty, as long as you're sort of doing that apples to apples comparison, then the differences among the different tools don't matter as much. So, okay, let's see. James from NRMCA came to my rescue and helped me with something and said the cement EPDs are publicly available on the NRMCA and ASTM websites. So that's great. There was a question about Hassam. One of your recommendation was to provide information at the mix level. It says as opposed to GWP. And so I think maybe I'll just ask this a little bit, that the clarification is that in current EPDs, you don't have to provide any information about the mixes. So we see the result, we know it's for a certain kind of strength, but we don't know what was in them. So Hassam, your recommendation was more, in order for us to do better comparisons, we do need to know what's in the mixtures. Is that correct?
Yeah, exactly. So one important and a big step towards that is to have regional mixtures. In other words, if we have a good representative of what is going on in that specific region in terms of the materials being used and in terms of the current practices and the technologies being used over there, these are important factors that are already, initiated and it's already, available. So once we have these mixed designs, we can definitely have a more, a fair comparison and apply consistent rules in our calculations as opposed to GWP values that we have already had as benchmark values.
Great. Yeah. And I think one of the things I want to clarify is I very much understand that what's in the mixtures is considered, by concrete companies, their intellectual property. So I don't think that in publicly available EPDs, that information has to be made available. But if you are running a procurement program where you are going to be making vendor decisions based on them, you could, like already, for example, on a construction project, that the owner will know what's in the concrete. So you could set up a similar thing where that information is private, but that is made to someone who's running that information through a calculator and doing comparisons. So, so I don't think that, like I said, we're saying all that has to be public, but it does have to go, it should go into comparison. So. Alpha Swinger from Portland Cement Association also came to my rescue and let me know that an EPD, or sorry, industry, let's see, what was it? Updated EPDs for cement will be published in about a month. And I think that's probably more from different companies. I suppose the industry average one, but maybe I'm wrong on that. Maybe it will be the industry average one. So regardless, check in with Portland Cement Association in one way or another, you'll get updated EPDs. There's a good question here about whether or not a PCR should specify a tool or calculator that must be used. And this is sort of an interesting question. Like, for example, in the most recent revision of the concrete PCR, they did get much more specific about the type of background data that should be used as a means of trying to improve comparisons. And while that is a step in the right direction, I still don't think it ensures that they can be, entirely compared, kind of going along the lines of different calculations. Now, the asphalt industry, their program has just used one calculator. And so that is one approach. They basically did that. So I don't know, as I said, for me, it kind of depends on what's the purpose you're trying to achieve. And if you really are trying to set up something where you guarantee that they can be compared, it's a bit hard for me to see how you get around that without having a single calculator. But I'm open to other suggestions. So. Doug had a good question about whether or not we should recommend adding 7-day strengths to reported EPDs. And I think, 7-day strengths, that would be great to get that, but I still think it doesn't totally get us around, if once we know 7 and 28-day strengths, can we still determine functional equivalence? My gut is probably still not enough. But the reason why I said that if you were going to set thresholds, it should be done with a multi-stakeholder process. We should probably try it out. Who knows? Maybe that stakeholder group decides, as long as we know 28-day strength and 7-day strength, we feel comfortable that's enough. So does it have to be more than 28-day strength? I think so. And that's why I recommended, I think the functional categories sort of get around that, but how much do we need? I'm not exactly sure. So.
Yeah, what I wanted to just quickly add to this was that maybe we can refer to different guidelines and codes to see what they need as an input for elements or the structural element design. If it is a pre-stressed element, or if it is a concrete element exposed to an aggressive environment, probably we definitely need to include characteristics related to the early strength or the durability properties. Or thinking about EPDs as a source for pavement applications, we know that maybe compressive strength wouldn't be enough for pavement designs, and specifying what we really need for pavement slabs or other elements as well. These are the things that we can refer to codes and guidelines to have a more clear point of view about what to include in our EPDs to have a fair comparison.
Yeah, great. All right, so back at the top of the hour, we got over 50 questions. I think we got to a lot of them, but apologies if we missed yours. Remember, you can contact us at cshub@mit.edu. And as long as you registered for this, You'll get a follow-up email that will say, here's the link to the slides and then also to the presentation in case you wanted to share it with someone or watch it again. And with that, we'll thank you and make sure to stay tuned for another webinar in the future. We look forward to continuing to engage with you. Thanks very much.
Thank you, everyone.